This is the third lesson on trig ratios. Specifically, we are going to be talking about application problems. So the first thing we're going to lay out here are some steps to solving problems using trigonometric ratios. So the first thing is that we need to identify what needs to be calculated. Okay, so that's either going to be an angle or a side. So is it an angle or a side? Okay, once we've determined that, we need to model the problem with a right triangle. So model with a right triangle. Okay, and we know it's going to be a right triangle because we can only use these trig ratios if we have a right triangle. So what model means essentially is just draw a picture. Okay, draw a little picture, a little diagram for yourself. The third step is going to be to label the sides. Okay, so that's obviously going to be opposite, adjacent, or hypotenuse. So op, adjacent, or hypotenuse. Okay, and again, remember that depends on what angle you're actually looking at. Okay, step 4 is to write an equation using trigonometric ratios. So write an equation, EQN just means equation, using trig ratios. Okay, and that's your SOHCAHTOA or SOHCAHTOA. Okay, step 5 is to substitute those known values. So that's essentially just substitution, right? Which we looked at over our review. So obviously if side length A equals 5, you're replacing A with 5. That's all that means, okay? Substitute the ones that you know. Lastly, we need to solve for the unknown. Okay, so some of these steps are the same as those first two notes. Obviously, there's just a couple more things we need to do when we're dealing with these word problems. Okay, so let's look at a couple of examples here and go through these 6 steps in order to find an answer. So example 1 says, while walking to school, you pass a barn with a silo. Looking up to the top of the silo, you estimate the angle of elevation to be about 14 degrees. You continue walking and find that you were 40 meters from the silo. Using this information and our knowledge of trigonometric ratios, calculate the height of the silo. Okay, so step 1 says to identify what needs to be calculated. So we're looking at that last sentence there. So it says calculate the height of the silo. Okay, so as soon as we see height, we know that what we're trying to calculate is that side length. Okay, specifically is the height of this silo. Okay, so we know what we need to calculate. We move on to step 2. So step 2 is to model the problem with a right triangle. So essentially all we're doing is we're drawing a picture, right? So we know it told us that you were 40 meters from the silo. So obviously we're assuming we're walking on somewhat even ground here, right? So that's going to be a straight line there. And that is going to be 40 meters. So I'll label that in a second. I just want to finish off my triangle here. It also says that the angle of elevation, okay, so think about that for a second, elevation, so you're looking up, right? So So elevation obviously means you're looking up. So that's that angle from here up to the top of that silo. So now we just need to label those sides. Okay, so we know that that distance was 40 meters. And we know that the angle of elevation was 14 degrees. Sorry, it's hard to draw little dots with this. 14 degrees. Okay, so we filled in all the information that we know based on the question. So again, it's important to kind of underline or highlight the information in the question so you can fill it in as you go. Okay, so we've identified what needs to be calculated. We've modeled the problem with a triangle. Okay, the next thing is to label the opposite, adjacent, and hypotenuse. Okay, so again, you kind of have to make the assumption that this would be a right angle here. Okay, so because you're walking on, say, even ground. All right, so we know that across from that right angle is always going to be your hypotenuse. We know that across from the angle that we're dealing with or that we're given is always going to be the opposite, which leaves this side length here as the adjacent. Okay, so we've labeled. Our next step is to write an equation using trigonomic ratios. Okay, so we need to figure out what ratio we're going to use here. Okay, so we know that we need to find a side length here. Okay, which means we need to use the angle we're given, the side length we're given, and the value we're trying to come up with. Okay, so we need to find the opposite side and we're given the adjacent side. So we think back to SOHCAHTOA, which trig ratio includes the opposite and the adjacent. That trig ratio is tan. Okay, so we have tan theta equals opposite over adjacent. Okay, so we figured out the ratio, and we have written that as an equation. The next step, step 5, is to substitute the known values. So substituting in the information that we know. Okay, so we know that theta here, which is just, again, the angle that we're given, is 14. So we have tan 14 degrees equals the opposite side, which again is our height. So that's the value that we're going to solve for. And our adjacent value is 40 meters. Okay. At this point, we're jumping into our last step, which simply says solve for the unknown measure. Okay. So when we're solving for the unknown measure, that means we need to isolate the variable. Okay, so again, we're isolating h. So in order to get rid of that 40, we're using opposite operations. It's right now it's being divided, right? H divided by 40. So the opposite operation there would be to multiply. Okay, what we do to one side, we have to do to the other. These will cancel. We're left with 40 times tan 14 equals h. Okay, again, just pulling out your calculator there. And you should get 10 meters equals h. Okay? Because this is a word problem, of course, we obviously want to make a concluding statement. So again, you need to be able to calculate it, obviously, but once you've calculated it, you also need to remember what you were actually calculating. So what we were calculating here is the height of the silo, so therefore the height of the silo is 10 meters. Okay, so we followed 1 through 6, and we have completed this example. So let's move on to the second one here. Okay, so example 2, it says a helicopter sights a campfire at an angle of 40 degrees from the horizontal. The helicopter is hovering 400 meters above the ground. What is the horizontal distance between the helicopter and the campfire. Okay, so again, we need to pull out the information from our question. So what is the horizontal distance? Okay, right away indicates that, again, just like example 1, we're solving for height here. Okay, specifically, we're solving for, not for height, for side length. We're solving for the horizontal distance, or the length between the helicopter and the campfire. Okay, and we'll be able to visualize that a bit better once we complete step 2, which is to model that with a right triangle. So, obviously what we're trying to find is the distance from this helicopter to the fire. Okay, so that has to be the first line segment we make. Okay, so it says a campfire at an angle of 40 degrees from the horizontal. The helicopter is 400 meters above the ground, so we know that the height of the helicopter, right, so that's going to make this line here. And of course, this is a triangle, so we just need to fill in that last. And this isn't perfect, but you get the idea here. Okay, so this is obviously our right angle, right, with the ground. Now we're filling in the information that we know. So we know that the helicopter sights a campfire at an angle of 40 degrees from the horizontal. Okay, the horizontal is just a horizontal line. Okay, so if we're looking at this diagram, we need to find that horizontal. It's just going to be the line that goes straight across your page. So this is telling us that this angle here is 40 degrees. Okay, it also tells us that the helicopter is 400 meters above the ground. So that means that our height here above the ground is going to be 400 meters. Okay, so we've now drawn our model, we've labeled all the information that we have. Okay, the next thing is to label, again, always the opposite, adjacent, and hypotenuse. Okay, because we are finding a side length, we know we have to use the angle we're given. So that's our reference point. So across from the 40 degrees is going to be our opposite side. Across from our 90-degree angle is our hypotenuse. And lastly, whatever's left over is going to be our adjacent. Okay, so step 4 now is to write an equation using trig ratio. So we need to figure out what trig ratio are we going to use here. So I know that I need to include the opposite side. I also, because I have that information, right, I also know that I need to include the hypotenuse. The reason I need to include the hypotenuse, which I'm going to just refer to as x, is because that's what we're trying to find, right? It says, what is the distance between the helicopter and the campfire? So we obviously need to include what we're trying to find. So I need a trig ratio that has both the opposite and the hypotenuse. Opposite and the hypotenuse. A campfire, sorry, 1 second here. A helicopter sights a campfire at an angle of 40 degrees from the horizontal. The helicopter is hovering 400 meters above the ground. What is the distance between the helicopter and the campfire? Yeah, okay. So we need to figure out the trig ratio that includes the opposite and the hypotenuse. Okay, we look back, opposite and hypotenuse, we know that that is sine. So we have sine theta equals opposite over hypotenuse. Okay, next step, step 5, is to substitute the information that we know. So we know that theta is 40. We know that our opposite side length is 400. And we know that our hypotenuse is simply x. It's what we're trying to find. Okay, so you will hopefully remember from that last lesson that we did. When we have our variable on the bottom, okay, we're going to solve it the same way, right? We would multiply both sides by x because multiplication is the opposite of division. But you might also remember that I told you a trick that you can just simply switch the location of these two values. So we actually just have x equals 400 divided by sine 40. Again, to make sure your calculations are accurate, you might want to just evaluate that sine 40 on your calculator. I'm going to do that here. So sine 40, so that is approximately 0.6428. Okay, so we need to do 400 divided by that number, which gives us 622. We'll just go to one decimal place, 0.3, and we are dealing with meters here. Okay, so that means, again, we refer back to the question, what are we actually looking for? So the distance between the helicopter and the campfire is 622.3 meters. And again, you would write that as a therefore statement. You want to be more specific than this. I just don't have a whole lot of space. The distance is 622.3 meters. Okay, and we have a couple more examples here. Just give me a second. Back. Grab the second half. There we go. Perfect. Two more examples here. All right, so example 3. So it says a sailboat that is 2 kilometers due east of a lighthouse sends a signal to the lighthouse that it is in distress. The lighthouse quickly signals the Coast Guard that is due south of the lighthouse and 7 kilometers southwest of the sailboat. What heading from due north should the Coast Guard take in order to intercept the troubled sailboat? Okay, so that was a lot of information. Thankfully, we have these images drawn for us on our page, right? So all we need to do is essentially connect them. Okay, so I'm going to start by doing that. Or actually, no, we should start with step 1. So what heading from due south should the Coast Guard take in order to intercept this sailboat? So this isn't asking us for any sort of distance, right? Which means that it is asking us for an angle. Okay, so that's the first part, right? Identify what we're trying to find. We need to try to find an angle. Okay, specifically, we need to find the angle that the Coast Guard needs to take to get to that sailboat. So let's draw the triangle first, just to make sure that you can kind of visualize that. So again, obviously this is straight down from this. This is straight across from here. And this is going to create an angle somewhat like that. And again, it's not perfect, but bear with me. Okay, so again, we can visualize, we can see that this is obviously going to be our right angle. Oops. Okay. Now we need to go back and figure out the information that it's giving us in the question. So it says the sailboat is 2 kilometers due east of a lighthouse. So the sailboat is 2 kilometers from the lighthouse. So that would be here, right? Sailboat, lighthouse. The east, that's sort of directional and not as important. Okay, the lighthouse quickly signals that a Coast Guard is due south of the lighthouse and 7 kilometers southwest of the sailboat. So that Coast Guard boat, which is the boat at the bottom there, is 7 kilometers from the sailboat. So that's this side length here. Okay, and it's asking what heading should the Coast Guard take to get to the sailboat. Okay, so again, the Coast Guard is down here. We can just label it if you want, so you remember. Coast Guard. This is the lighthouse. And this is obviously the sailboat. Okay, so what angle should the Coast Guard take to get to the sailboat? So what angle we're looking for is this angle here. Okay, and we're just going to call it X. All right, so that one was a bit more tricky to draw that visual just because we kind of had to dissect the information a little bit more. But again, hopefully you will be able to come up with that diagram on your own. It is one of the trickier elements of this lesson for sure. Okay, so we figured out what we need to find. We need to find that angle there that's labeled X. We've drawn our diagram, so we need to move on to labeling the opposite, adjacent, and hypotenuse. Okay, so again, the angle that we're dealing with across from that is always going to be your opposite. Across from the right angle is always going to be your hypotenuse. Whatever's left over will be your adjacent. Okay, so the next step is to choose our trig ratio. So obviously we're trying to find an angle here. So we need to use the two side measurements that we have. So those two side measurements are opposite and hypotenuse, which means we need to use sine. Okay, so I'm going to start by just writing out that equation. So sine theta equals opposite over hypotenuse. Okay, next step is to sub in the information that we know. So we labeled our angle X, so I'm just going to change that. You could just leave it as theta too, it doesn't really matter. The opposite side length is 2. The hypotenuse is 7. Okay, because we are trying to find that angle, this is where we have to use that inverse, right? In order to get rid of sine from my left-hand side here, I need to take the inverse sine of both sides. So I have X equals sine -1 of 2 over 7. Again, typing that in on your calculator, you're probably going to do 2 divided by 7 and then take the negative sign of that. You should get 16.6 degrees. Okay, of course, we want to refer back to the question, what did I actually just find? And then use that to make your therefore statement. So we want the Coast Guard to head 16.6 degrees. And again, the direction doesn't really matter, but it would be northeast. Coast Guard. Therefore, the Coast Guard to head 16.6 degrees northeast to the sailboat. Or we'll just call it the boat. Okay, so that was that angle measurement X that we calculated there. Okay, one last example here. Okay, example 4. So, safety bylaws state that for a ladder to be stable, the angle the base of the ladder makes with the ground should be between 70 degrees and 80 degrees. A safety inspector at a construction site notices a painter on a 10-meter ladder that is leaning against a wall. The base of the ladder is 1.5 meters away from the wall. Does the inspector have cause to be concerned? Explain. Okay. So for this one, we are looking at an angle, right? Because it's telling us the angle that this ladder makes with the ground should be between 70 degrees and 80 degrees. Okay, it's not asking us to determine a height or a side length or anything like that, so we know it has to be an angle. Okay, our second thing to do is to draw a diagram of this. Okay, so you might have to think a bit more for this one. Okay, but basically, hopefully you've used a ladder or you've seen somebody use a ladder. Obviously, you lean your ladder up against a wall. So the first thing I'm going to do is just make this my wall. Okay, and that ladder is obviously going to be on the ground and it's going to lean against the wall. Okay, so closing in my triangle here. Again, not perfect. Obviously, these lines should be straight. labeling this side my ladder. Okay, and the question tells us that that ladder is 10 meters high. Okay, obviously this wall would keep going. The wall wouldn't necessarily stop. And it also tells us that the base of the ladder is 1.5 meters from the wall. So the distance here is 1.5 meters. Okay, the floor and the wall will always make a right angle. Okay, what it's asking us, what we determined in step 1, is that we're looking at this angle here, right? It's telling us specifically that angle, for it to be safe, needs to be between 70 degrees and 80 degrees. So we just need to make sure that that angle is between those two values. If it is, we're good. Okay, if it's not, then the inspector should maybe be concerned, maybe this is unsafe for this person on the ladder. Okay, so next step is to label our sides. So again, opposite of the angle we're dealing with is the opposite side. Opposite of our right angle is always our hypotenuse. Whatever's left over is our adjacent. Okay, so we need to figure out which trig ratio we need to use. Okay, looking at this, we can see that we need to include both of our side lengths, right? Because we're dealing with an angle. In order to solve for an angle, you need two side lengths. So our two side lengths are our adjacent and our hypotenuse. Again, hopefully you have that SOHCAHTOA in front of you. Right away, you can see that cos involves both the adjacent and the hypotenuse. So we're going to start by just writing that out. So we have cos theta equals adjacent over hypotenuse. Okay, next step is to sub in the information that we do know. Okay, we don't know the angle, but I have labeled it x, so I'm just going to change that variable there. I know that my adjacent side length is 1.5 meters, and my hypotenuse is 10 meters. Again, we're solving for an angle here, guys, so we need to use that inverse of cos. Okay, think about it as the opposite. So we need to take the cos -1 of 1.5 over 10. Again, on your calculator, you're probably going to do 1.5 divided by 10 and then click equals and then take the cos -1 of that. You should get approximately 81.4 degrees. 81.4 degrees. Okay. Last step, again, you're always going to refer back to your question there. So it says, does the inspector have cause to be concerned? Remember, he should be concerned if that angle is not between 70 and 80. So basically, if it's less than 70 or if it's greater than 80. Okay, as we can see, 81.4 is obviously a little bit greater than 80. Should he be super concerned? Probably not, right? Like that's not going to make a huge difference, but technically that is greater than 80. So in our concluding sentence, we would say yes. Does it say the inspector? Yes, the inspector should be concerned. And we're just going to say because 81.4 degrees is not between 70 degrees and 80 degrees. Oops. 70 degrees and 80 degrees. Okay, so again, yes, these questions are a little bit more tricky because you have more steps, right? It's not telling you what you're solving for. It's not necessarily drawing you a diagram. So if you are following through those steps that we listed out on the first page, I'm sure you will be fine, but just make sure you complete all the practice so that you have a good handle on how to do these application problems.